evaluating trig expressions when your angles fall on the quadrant boundaries, like 0, 90, 180, 270, 360, or their radian, correspondent. And so, since you can't draw a triangle to create and evaluate angles like that, we're going to use a different approach, which is sort of based on the unit circle. And some of you might be familiar with unit circle. It's a circle of radius 1. Not too bad. And so if the radius is 1, I can call this point 1, 0. This point up here is 0, 1. This point right here is -1, 0. And then down here would be 0, -1. And the idea is that you're going to look at just an arbitrary angle, call that theta. And when you have that arbitrary angle theta, and again, eventually we're going to use this when we get to the quadrant values, but just for now, our theta is generic, so we can still drop a triangle down here. So there's an arbitrary point here, x comma y, that's associated with that theta, which means that this length going along the base of it would be length x, the height would be y, and then since it's a unit circle, we know the hypotenuse has a length of 1. And if we still think about our sine of theta being the opposite over the hypotenuse, we say it's y over 1. But since our hypotenuse is 1, we're going to associate the sine function with just y, or just its y component. And then similarly, cosine of theta is still adjacent over hypotenuse. But since the hypotenuse is again 1, the cosine function we're going to associate with x. And then tangent of theta would be opposite over adjacent. So here would be like y over x. So again, it's looking at just the two components of this point that's on the unit circle. Our reciprocal functions would follow the same. So cosecant of theta is the reciprocal of just the y coordinate. Secant of theta is just the reciprocal of the x coordinate, and tangent of theta is just the reciprocal of, cotangent of theta is just the reciprocal of tangent, so it would be x over y. So the unit circle, if you scale your triangles back to a hypotenuse that's always a length of 1, and you situate it in a unit circle, then you can associate the trig values with simply the x, the y, or a combination or reciprocal of those values. So we're going to do something very similar to that, like for example, 90 degrees. So if I think about where 90 degrees would exist on the unit circle, be up here at the top, right there, at 0, 1. So 90 degrees, if I can associate the sine function with the y value, the y coordinate at 90 degrees is 1. So I would say that the sine of 90 is equal to 1. Similarly, let's go to 360 degrees. So 360 degrees, it's a full circle around. We're sitting here at the point 1, 0. So it does require me to remember that cosine relies on the x, and in that case, the x value is 1. So it's very similar. Okay, tangent of 180. So we're going to draw 180 degrees, which sits over here. And that point is -1, 0. So again, tangent relies on, tangent of theta relies on knowing that it's the ratio of y to x. So look at the y value of 0 to the x value of -1, 0 over -1, which is fine to do. It's equal to 0. Okay? And then secant of 90 degrees. So 90 degrees we know is up here at the top. That's 0, 1. And again, it relies on secant that we know that is the reciprocal of x. So 1 over 0. But that's a problem. 1 over 0 is undefined. So in this case, our value does not exist, or DNE. Okay, and again, some of you might be really familiar with sort of these quadrantal values or a unit circle approach. So if you are comfortable, you could put a pause on the video and try the last ones on your own, or continue watching along. Okay, so I'll transition maybe to a different color. So cosecant of pi over 2. So pi over 2 radian. So you're up here at the top of the unit circle. Its coordinate is 0, comma 1. We do the reciprocal of the y value since that's cosecant. So 1 over 1, which is still going to be 1. Cotangent of pi. So pi is over here at quadrant, or sorry, at negative 1, comma 0. Cotangent is the reciprocal of tangent. So cotangent would be x over y. So we get negative 1 over 0, which again, we are in a situation where we get a value that does not exist. Okay. Sine of 3 pi over 2. So now we're down here at the south pole, so to speak, at 0, comma negative 1. And then sine would be the y value, so negative 1. And finally, cosine of pi. So pi, I could have used the same diagram above, but that's all right. I'll use this one. We're still at negative 1, 0. Cosine is the x value, so we get one more time a value of negative 1. So the quadrantal values work because we're using a unit circle approach. Okay, so certainly give those a try, and we'll take a look at the next section tomorrow.